Greeting from EGS India. This is your webinar host Santoshi from Marketing. Thank you for coming online to attend this webinar on design for manufacture, essential for successful product design. A few housekeeping updates. All microphones are muted and cameras turned off to save bandwidth in case attendees have issue with internet connection. So now you may participate using chat for sending message to the presentation team. We welcome any questions or clarifications on the subject topic. The same will be addressed upon the completion of webinar presentation. Thanks for the cooperation, and now let's get started. Design engineering is the pillar that helps drive innovation and technology development in manufacturing industry. Mistakes committed in design affect the organization, customer, and society at large in varied perspective. As a part of constant endeavors from EGS India to strengthen the design ecosystem, we are starting a series of webinars on providing strategies for design without errors. So now over the next 40 minutes, we have Mr. Natarajan Ramamoorthy, the Managing Director of EGS India, to present on the topic of the day, design for manufacture, essential for successful product design. Mr. Natarajan has over 36 years of experience in product design, finite element analysis, design verification, validation, and development. His courses of FEA are well known in the industry and academia. He has a master's degree in mechanical engineering from the University of Toledo, Ohio, USA, and started his career with Ford Motor Company in Ford Scientific Research Laboratory. An ASME certified GD&T technologist 2016, he has been incorporating GD&T practices in product design and development in addition to consulting with industries in varied vertical segments. He is an active member of the Bureau of Indian Standards with MED section assisting in evolving standards for material handling equipments in addition to drawing standard committee. I invite Mr. Natarajan sir to take over the webinar to present his topic on design for manufacture, essential for successful product design.
Thank you. I hope you are able to hear me. Good afternoon to every one of you. The topic design for manufacture is one of the most complex topics that keeps challenging mankind all the time in different kinds of product development across many vertical industries. This topic is very comprehensive in terms of its applications in various areas. So I'm going to be giving you an overview with peppered with some examples. I hope you find this useful. When it comes to DFM, DFA, DFM and A, design for manufacture, design for assembly, design for manufacture and assembly. Assembly is a part of the manufacture when it comes out of the shop floor. So they are all synchronous together, synonymous. So when we look at essentials in successful product design, 9 out of 10 times that the issues that raise as a result of product manufacture comes as a result of incongruities between design, manufacturing, and inspection. So how to look at it upfront at the design stage? This is what we are looking at. And what is the mainstay? What is the goal for doing this? Quality and the reliability of the product. So the brief would be first with about EGS India and then the goal of DFM by examples and then checklist and then the question and answer session. We employ different manufacturing methods, different assembly methods when we are putting things together. So I'll try to make it as comprehensive as possible, but this presentation is not going to be the summary of all the things that needs to be done, but gives you an overview. EGS was started in 93 with the vision of engineering development through effective partnership for those who do not know us. And we try and address the vision by 3 mission statements, namely incorporating or imparting leading edge technology through training and development, problem solving and new product development through our consulting services. That's where we started. And providing software solutions, both software from Dassault Systems, which is our parent organization for Solidworks suite of products, and the 3D Experience suite of products, as well as our own products developed under the Life brand. Since 1993, we have been working with a lot of different customers, specifically from the area of engineering services in new product design and development, FEA, CFD, and validation, and verification, value analysis and value engineering, and software sales and support, as I told you earlier, for Solidworks suite of products. Live QC Tools is our quality management system that we have recently launched, and we have acquired customers as well. And then design automation and CAD customization is one of the most important activities where we capture the knowledge in a company and put it in reusable form. And then we have the training under a division called as academics, where we provide training in finite element analysis, geometric dimensioning and tolerancing, tolerance stack-up analysis, DFM, DFA, FMEA, the latest VDAFS, AAG VDAFS format, and then SolidWorks suite of products. We give the training as well. Now, in design for manufacture, the goal, why do we need to do design for manufacture? Keeps staring at you. When you look at different kinds of Pareto diagrams in your organization with regard to the issues, with regard to what kind of downstream problems that you're facing, and either at your customer place or in your manufacturing or with your supplier or any combination of these. So the input for DFM, that is design for manufacture, the learning for that needs to come from our existing data, which is already available inside the organization. For example, here you see the defects type and the number of defects. It will tell you which are the area where you need to concentrate upon, whether you have missed out on anything with regard to the DFM aspects from a design point of view. I'm not saying that these issues or defects are normally related only to design. Then what are the issues that can be solved by design? That's what we need to be looking at. We need to take a holistic approach. So one of the examples is the Pareto that is shown over here. Another is, a typical example is the warranty cost that comes as a result of the quality or the reliability issues that surface, probably because of the manufacturing related issues that could surface in terms of a quality or reliability effect on the product subsequently down the line. So when you look at all these things, you look at the broken seal, the improper handling, the improper lubrication, material defect, overheating, overloading, vibration, and all those things. Some of them may be related to design, some of them may be related to the manufacturing process, the inspection process, or some of them may be related to the customer usage. Or it could be a combinatorial effect of all of these put together. So in other words, design cannot divorce itself saying that this is a quality problem or this is a customer issue, customer usage issue. They still have to nevertheless have a satisfied customer, come what may. So from that point of view, when you look at all the downstream problems and you say that these problems, I'm going to look at it from a design point of view, how would I go about looking at it? So this is where we come in with regard to this intent of this webinar. So the goal has to be very clearly given as to why am I doing DFM? What is the outcome of this DFM that's going to come about? What are the benefits with regard to the organizational as well as the customer experience with regard to our product that we are giving to them? For that, when we look at it from a design point of view, we have been reiterating this proven process in design for quality and reliability across many webinars. In fact, this is one of our mainstay process that we employ at our organization for any new product development or new technology development here. So if you look at this, you will see where design for manufacture is sitting in the whole scheme of things. At the end of this is the GD&T drawing that comes out. Right? So the influence of design for manufacture in terms of the CP/CPK or its influence on the PFMEA, which is tethered to the DFMEA given over here, or in terms of the tolerance optimization, or in terms of the cost of precision. In all these cases, you would be in a position to look at the overall bird's eye view of this DFQ&R process and see how to relate to this. At the end of the day, everything is process driven. In every one of the steps, like for example, in design for assembly, or design for performance, or design for safety. In all these things, we need to have checklists. If these checklists are going to be complied with, are going to be addressed, then first time right will be a no-brainer. Otherwise, we come back and keep revisiting the design all the time, and we have to do them nevertheless anyway. But it's going to cost the company money, time, and image in front of the customer. So with that emphasis, let's move forward and look at what are all the DFM considerations. First is cost. Remember, since we are looking at it from a design point of view, we need to understand that the product cost, 85% of that is determined by design. 15% is the rest of the job functions in the organization. So that's why cost comes first. Next, you could have scrap and wastage. If 5 to 10% of your scrap and wastage can be improved upon, that is your bottom line money that your company you are saving. So if I look at it from that point of view, if I look at DFM from these objectives, from these paradigms, then it becomes a meaningful exercise. Otherwise, it's just only a fulfillment for either an audit, for a risk point of view, or from any other point of view, just because the customer asked for it. But this is important from our organization point of view. Third one is the productivity. Next one is material, capability, environment, assembly, operator needs, and tooling. These are all the 9 segments under which we would be looking at DFM with a sense of purpose. Now let us look at each one of them separately. In cost is, how do I go about looking at cost, or reducing the cost, or minimizing the extra expenditure that I would have otherwise incurred because of the way we have set up the processes, the stage gating part of it. When we look at it from that point of view, remember, we are adding value to the product. If the product is going to be priced higher and the value of the product as perceived by the customer is higher, he is willing to pay you the money extra. However, if that is not meeting his expectations, we bleed. So we look at costs from incurring inner costs from our internal cost point of view. What are the influencing areas where we need to look at? The number of stages. For example, one of our customer is developing a sheet metal component in 3 stages. The thickness of the standard material component thickness is 3.4 millimeters, let us say. He goes through the 3-stage forming process and it comes down to 2.8 or 2.81. That's a significant reduction in thinning. As a result of which, what happens? Your durability takes a hit. So if you say 100,000 cycles, there's no way you can guarantee 100,000 cycles if you have taken 3.4 as the nominal in your design. So if I increase the number of stages, then my thinning can be controlled because of strain rate. It is an additional cost, no doubt about it. You're incurring a cost, but look at your durability expense when the problem is reported by your customer on the field, and the customer happens to be sitting in Japan or in US, and you have to airlift a component to replace the shipment, and he's asking you to come over there to do a 100% inspection. What is the cost? That's 1/11 is what you're seeing on the tip of the iceberg. The other 10/11 is sitting underneath the ocean, where these kinds of things come into picture. This is an example. Next one is material. One of the DFM gurus, what they say is, as much as possible, keep the number of variability of materials to the minimum. Why? For every material, you need to have 2 or 3 suppliers at least. For every material you have it, and let us say you are dealing with 10 different types of steels, you just got probably 3 into 10, 30 vendors, or common vendors, means you are adding more risk for the same material across many materials for the same supplier. So de-risking ISO tells you. So keep the number of materials lesser so that you have enough reliability data from that material. Are you with me? And then you put it in such a way that that material, you have enough confidence that you are not going to have manufacturing issues as a result of that material. Because you go through your PPAP process when you change the material or the supplier, right? Anyway. So you have done all this due diligence. You look at all these aspects. So the material cost is going to be significantly affecting you. Third one is the cost of precision, which everybody knows. 18 plus or minus 0.5 or 18 plus or minus 0.5. 1000 microns or 100 microns, which is going to make you pay more initially, but which is going to make you pay through the life of the product subsequently. Then the cost of quality, it could be either cost of poor quality or it could be cost of precision, as I told you earlier. Here we are talking about cost of poor quality. Then the power consumption. Why should design be worried about it? Finally, all these costs add up, right? And it's going to be in the price of your product. Your margin keeps coming down. Your KPIs get affected directly or indirectly. Next is very important thing, cost of a standard product bought from outside or built up from inside. As much as possible, DFM advocates buy standard products and integrate it. The advantage of that is the reliability of the product which you are bringing in is known across many assemblies. You will be in a position to build up the reliability on the new product based on these existing components which you are taking from standard products, as a result of which your reliability predictive model is much more better. And the last one is manual versus automation. Should I introduce automation or should I go with manual methods or should I use a combination of both? Either which way you look at it, some of them are upfront costs, some of them are running costs. So when we look at DFM, we need to look at, when we are looking at it through the prism of cost, then we need to look at these 7 parameters. So the checklist has to have information in all these areas. Next one is material. Now we know that the carbon border adjustment mechanism is in force in Europe. In other words, the more carbon footprint you leave in your manufacturing process, more you are going to pay in terms of tariff when your customer imports it into the European Union, which means how much of value addition you are doing on your component, on your supply component, how much of them is sustainable, we need to look at. So from a manufacturing point of view, unless in DFM, if I don't look at manufacturability, from a point of view of sustainability norms, my CBAM bill goes up. Who is going to pay for it? We are going to pay for it. Customer is not going to pay for it. This is threatening us from January 1st, 2026. Already people are going through the trials right now from Indian importers in certain segments like cement, steel, electric vehicles, electric technology. In a lot of these critical sectors, they are imposing this. What they are saying, we have put all these norms in our country and our product cost is up. If you have not put it, you need to pay for it because we are looking at clean energy. So this is here to stay. Our government is also helping our manufacturers to achieve these goals. No place to look beyond except DFM. The next one is environment in terms of corrosion, recycling, and disposal. For example, you are keeping the material inside your, I'll give you an example, especially with regard to corrosion. There is something called as e-coating and top coating. When you buy a car and 2 years later down the line or a year later down the line, when you open the door, at the bottom of the door, there is a small rust sitting there. How do you feel? You feel that the car is not qualitatively better as you imagined it to be earlier, right? So you have that sickening feeling that something or the other is going to go wrong with the vehicle. That's how the customer perceives when he looks at your product. In fact, in one case, I will tell you, one of our customer used to work with a Japanese collaborator. Over a period of time, they have started developing the technology themselves. So they started producing the products in India and they started improvising on the product. And the next version of the product is already in the market. So one of the customers had a complaint and the service engineer went from there And the design manager also went to the customer's place because the efficiency of the system was under question. When they went and looked at the company's product, they saw the Japanese product also there, and they saw their own product after 2 years of usage, but within the warranty period. Remember, 3 years warranty. When they looked at the product which was given by the Japanese 10 years earlier was looking new. The product which was given by the customer whom I am referring to, it had the rust river, you know, when the water keeps on dripping, you will get a rust trail on the external sheet metal cabinet that was there. So the customer looked at my customer and said, this is your product. This is your product from your erstwhile collaborator. It is 10 years old. Yours is only 2 years. Look at the rust on your system. What was the reason for the rust on the system? They had shortcut the coating process. In terms of value engineering. Where does it affect? Will that customer buy the product again? So when we put all these checklists together, the customer feedbacks in terms of these have to be there in the DFM checklist so that you go through every one of them so that you have not violated any one of those things. There are no shortcuts to success. So you are able to, from a design point of view, you have looked at it. So same is the case with recycling and disposal. Today, it is absolutely important after the end life of your product, how is it going to be there? So for that, the material consideration is there. For a cheaper cost, you go and look at it. You buy the product, but then you have a problem with regard to the disposal of it because of the alloy that is sitting inside. You cannot recycle it just like that. Then what happens? Then life versus warranty. You have your warranty issues, you go back to your drawing board, you change everything, you go back to your manufacturing processes. It came as a result of the pre-stress on the system. It influenced the life of the component, as a result of which it influenced your warranty and your RMA, return merchandise authorization claim, and that brought down your profitability. We need to look at it upfront at the design stage. The manufacturability part of it from a material, both from ductility and malleability, has to be looked at. The lesser the ductility, the more the brittleness. More the brittleness, lesser the ductile failure. High cycle fatigue issues will happen if the ductility comes down. So are we going and checking on the line the material and trying to get the graphs every now and then to check this ductility, to check the inward quality inspection? Are we doing it from a design? But the quality is supposed to do it. Yeah, quality is going to do it, but you need to do a random check. Why? Because it directly influences your performance of your system. The long-term degradation, all these aspects have to be brought in. The handling, the thermal stability from raw material to finished goods inside your factory, not outside, inside, because it affects your tolerances, right? And have we looked at the availability and the adaptability of the machines that are already available for the design that we are proposing? In all these points, you have to put the checklists and you have to, this is a live document as long as that particular part of the product is in service. The next one is please look at assembly. This is your iPhone. I'm sure if you're owning an iPhone, you don't want to open it and see it like this. But you can learn from this as to how they have put in the small real estate space so much of assemblies, parts, putting things together, and it works right all the time. These are all millions of pieces coming out of the line. And the real estate that takes the maximum amount of space is your screen and your battery, nothing else. Why am I talking about this particular thing? The reason why iPhone, though it is 3 or 4 times more expensive than a conventional cell phone, is popular is primarily because it is the operating system and the product are designed for each other. In other words, as the consumer wants it, the customer has to design and give the product. It's called made to order, make him feel special. That's exactly where design for manufacture comes into picture. So you look at this. It is a 2024 patent from Apple. This patent is not for some electronics item. It's not for some Bluetooth technology 5.0, 6.0. It is for assembly, folks. They have patented it for assembly. They are coming up with a unique assembly process and they have patented it. They are getting a leading edge over the other competitors because they have taken this assembly process and patenting it. So in other words, if you are doing a DFM and in your company, you have the ability to patent it, keep it as a unique process. This is where the wealth of the knowledge that we build over a period of time lies, and the country benefits from it. You know, this is a standing example of a DFA right here. DFM, DFA. This was done last year. It is already given. This patent number, please go and search for it. You will see it. How much are we missing out? So instead of looking at DFM only from the point of view of a rigorous checklist, please look at it holistically from a point of view of containment of your IPR, influencing the assembly process, influencing the manufacturing process, patenting it, and keeping it as a proprietary thing that your competitors cannot touch. This knowledge revolution is important for India and its manufacturing enterprises. So in assembly, we look at different ways, snap fits and clips instead of, and self-tapping screws instead of fasteners. Why? Because every fastener requires a hole and every hole requires a drilling and every drilling requires a fixture. And that fixture could be a locating fixture and subsequently it could be an inspection gauge. It adds up, adds up, adds up, adds up and adds up. You put that in terms of snap fit clips and things like that, that price comes away, but then your mold cost goes up a little bit. To do a fine balance between one and the other, you have hit the home run. Poka-yoke, you have to conditionalize it at your design stage. Absolutely. If you ask me, is design responsible for it? Absolutely, they are responsible for it. They are the drivers. The executors are the people on the manufacturing on the shop floor, but it comes from here. The non-interference with regard to the assembly aids that the operator uses. For example, in a suspension spindle, we always give the socket head clearance on the lower ball joint assembly, primarily because you cannot otherwise turn it. Nobody is going to turn it with a spanner. There's a power tool which is going to be used, which means you are going to remove some of your material on the suspension spindle right next to the area where the spindle shaft is sitting. Imagine the amount of durability issues you will get into. But this is a part of design for assembly. You can't escape it. So you need to look at it. Another example is safety. I'm coming down to a little later down the line. It should be automation friendly. First, we had batch manufacturing with the assembly people. As the number of volumes started increasing, we started automating. We started seeing some money. So now I'm putting money back into automation and I'm trying to increase my throughput so that my customer waiting time comes down. So in that automation friendliness, we need to look at it from a design point of view. Absolutely, yes. The switch gears used are proprietary technologies. I'll give you an example. A company manufactures switch gears. The assembly sequence is proprietary. It's a copy-proof design. So there are only 3 places in which it is manufactured, the switch gear. It is manufactured in Sweden, it's manufactured in South Africa, it's manufactured in Singapore. It's imported into India and it is used here, paying duty. In spite of paying duty, they don't want to give the proprietary technology to people in India. You see that? They are developing the switch gears in India, but they are using an assembly component which is imported. Why it is imported? Because it is having a proprietary assembly process. Again, an IPR issue. So please don't look at it design for assembly and design for manufacturing as something like a less important chore. So the least effort in assembly has to be looked upon from a design point of view. Shortest cycle time and rework, no brainer. Ease of handling. Customer friendly. Why customer friendly? A lot of times why do you think everybody is lining up to go to this furniture company in Bangalore? What is the name of that? The European company. I forget the name. They go and they buy the unit from there. Why is that? IKEA. Thank you. God bless you. Because you can assemble it yourself, right? And they want that I built it. I own the product. This is another way of looking at it. So if you develop a product, you don't assemble it on your assembly line, put it as an assemblable kit, give it to your customer and reduce the cost a little bit, give it to them, give them the installation procedure, they do it, they own it. Look at it from that point of view as well. Then self-aligning, self-locating, safety assured. This is absolutely important. With so many laws coming in. Disassembly friendly during service. Say, I will give you recently an example where to replace a component on the inner, they are on the side of the object, they had to open the entire unit from inside, and from inside it was fastened outside, and they had to remove it. I don't want to tell the name of the product. It is used in your kitchen. The customer would not go back to that person again. Avoid specialized tools in assembly process. Keep it simple and stupid. KISS. This is enforced across by the Japanese quite a bit. Keep it simple and stupid. It's called the KISS factor. We need to look at it and emphasize it. Then eliminate the fine tuning and manual calibration during assembly. I'll give you an example. This is published. This is available online. Fiesta car produced by Ford. The rear tail lamp would not fit properly. There was one person who used to take the tail lamp come from the supplier, put it in hot water, soften it up, take it, adjust it, put it on the line. Can you believe it? This used to happen in Ford India. Now the company is not there. I saw it on the line. They called us to come and help them to fix the problem. Scrap and waste. Next, stage-wise nesting, we can do it. Open source softwares are also available. If you don't want to pay for it, you can do it using this. Take all the sheet metal components, put them together on the developed plan, put it on it, get the utilization. This is a no-brainer. Everybody is doing this. Why I should emphasize this in this presentation today? Look at the scrap on the black image. That scrap area is the area in which you need to put the next part when another part comes up. So when you're doing a new product development on another part, you go back and say, hey, there was some material already available which is going in scrap. I'm going to use that material and I'm going to include this in that material itself. So I will use the same sheet metal thickness, the same grain direction. I will reinforce it, put it in, use these materials so that it keeps on filling up, so that my piece scrap keeps on coming down as more and more products are being produced by me. So don't look at it as only for one-time occurrence. This needs to be done throughout the new product development that we keep doing in our office all the time. The waste management of time, resource, and material. This is absolutely important. You need to observe, okay, this particular station manufacturing is taking 5 minutes. How can I reduce it to 3 minutes? What I should do from my side? Okay, I don't need to have a fixture. The setup time is taking 1 minute. So I'll put one of the components itself as a fixture, use that and go about doing it. So then I don't need this. I don't need to compensate for the tolling tolerances there. Think like that. The Japanese are adept at looking at waste management all the way through. The place where they search for their money is in their scrapyard. So they want their scrapyard to be non-existent. So time, resource, and material, all three wastes, looking at it from a DFM point of view. Waste during handling, usage of standard sizes is dictated, mandated by DFM process gurus. And then tolerance maximization and end of life, how do we need to take care of it? Tooling. This is the most important thing because this affects everything else. That's why I've given a very small image and very large amount of text. Sir, why I should bother about tooling? Some amount of your usage tolerance is going in fixture designs, right? In fixtures, right? In your locating fixture, manufacturing fixture, your jigs, your what is that? Your inspection fixture. Also, certain amount of your 10% of your tolerance is eaten up. So your working tolerance keeps getting shrunk. So if it's a fixtureless design, that is amount that design manufacturing has it. So who is going to do fixtureless designs? Design has to do it. Denso produces starter motors and alternators where the housing itself, motor housing itself, alternator housing itself is used as a fixture. Shortest loading, unloading and changeover time. How? By putting the number of features on our parts that way. Machining support to achieve required tolerance. I have put 70 microns. Now I am seeing leakage. I am reducing it to 5 microns. Already with 70 microns, I am not able to achieve it. How can I achieve it with 5 microns? Put enough locating pads. Put datum targets on those. Give it to those people. Visualize this, folks. And your clamping pressure that comes in. All these have to be taken into consideration. So the machining support has to adhere to this very carefully. The stiffness of the component has to be in such a way that it's not compromised. Avoid tight bends, sharp corners, undercuts, and non-standard holes and shaft sizes. This is absolutely required, especially the last one. Non-standard sizes should be avoided. Why? You can buy it from the market and put it in. Design it for what is already available. Incorporate uniform wall thicknesses, whether it is plastic or castings or whichever way you look at it, because cooling affects it. Draft angles and stiffness for clamping and cutting forces. Stiffness for clamping and cutting forces. I repeat, stiffness for clamping and cutting forces. We don't look at this in design. We need to look at it. Otherwise, our manufacturing process capability suffers. I told you another one, right? Capability that suffers. Enhanced tool life by employing standardized feature sizes. Keep it in library, your Solidworks or whatever CAD you use. Keep all features library, part library, assembly library, use them. Reusable fixture design, fixture friendly designs. Reusable fixture friendly designs. Already a fixture is available. Why I should make a new one? Design it for that. Eliminate, avoid multiple setups and operations. What do I do this? Sir, multiple setup is required because I'm having multiple datums. Why are you having multiple datums? Because my assembly sequence is having multiple sequence of assembly. Integrate components, make fewer parts, keep the assembly simple, reduce the number of setups. I gave you the answer as well. Symmetry by design to achieve balance in molding, casting for balance filling as well as for uniform cooling. No brainer. Smoother transitions for material flow. And then least material removal while maximizing tool. When you keep it close to the standard thicknesses, the material removal is the least, right? I take a standard 12 millimeter thick plate and I reduce it to 11.75. I'm okay with it. Instead of taking 16 and reducing, shaving material off. I've seen company where they do it, 16 brought down to 11.75 or 12. I want finishing elements, sir. That's why I'm not able to use the standard 12 millimeter. Okay, what compromise can you do for 11.75 on your design? How can you compensate for it so that I use only standard thickness? Come up with your final element report. Do the validation, show it. Use only standard. You put yourself in a constraint in a bind, you get better designs. Constraints always give you better designs when challenged. Maintain the depth to diameter ratios. Your software already has all these rule books sitting inside. You can put them into your DFM Express. It's there. You can put it in so that the tool does not wander. You don't have non-uniform tolerance zones coming up, and also for easy chip removal. Then the operator needs I need to look at from a design point of view. Sir, you are asking every one of them to be looked at from a design point of view? Absolutely. If design can fix it, so much of grief down the line can be dispensed with. Occupational safety. What occupational safety? I'll tell you, instrument panel going inside a car. He cannot bend down and put it inside. So the instrument panel sitting inside the car, the mounting points have to be above the H point. H point is the hip point. Because if he keeps on bending down and lifting, bending down, lifting, he has to go to an orthopedic doctor. That is occupational safety. So we can't allow that to happen, right? We need to look at it from that point of view as well. So if I'm designing a machine, I need to put up a step-up platform, which is already available, so that the person does not go in and remove the component by exerting his lower back effort more. He's bending forward and then removing the component. No. Access friendly, easy to handle, free of sharp corners, avoiding repeating and strenuous movements to prevent fatigue. These are all the requirements. Have we taken care of this? Are we introducing an orthopedic problem in the operator because of the way we have designed? Is the person getting a cut or a nick on his finger every time, and he's having a sore thumb all the time throughout the week because of the way we have designed? Sharp edges. Empower gravitational assist during part and assembly handling. This is there for even part design as well as for your SPM's designs and things like that. Every design is a design, right? So less or no human effort of repetitive nature. Now look at this productivity. See this one at the bottom. Ford Motor Company, you know the big end of a connecting rod, right? Small end of the connecting rod, big end of the connecting rod that gets split half, then you will put it together. Ford, when I was there at Ford, during that period, they patented this in 91, 92. I was there till 93. The engine division patented this. What they did, they took the unit and they broke the big end. The moment you break, it will split it into two pieces arbitrarily. Then when you put it together, they will fit as if there is no parting line. So the methodology to break it, they patented it. Till today, it is in use. Till today. Honda and other people have adopted it by paying royalty to Ford for that technology. So fewer part features required for assembly. I repeat, fewer part features required for assembly. Reduced setup time. All this is directly functionally relating to our product design, folks. As long as you protect the function, the bare minimum required to protect the function, the bare minimum required to protect the fit, the bare minimum to enumerate the form, the better we are. Fewer setups for multi-stage manufacturing, implying simpler assembly. Fewer things gone wrong with checklist-driven processes by design, and reduce the cycle time, maintenance-free designs, service-free designs. I repeat, maintenance-free designs, service-free designs. This is your USP for your product, for your customer. For example, I take a bearing, I take a seal. I buy a bearing separately, I buy a seal separately. Now I go and buy an integrated seal cum bearing. Which is better? Seal cum bearing is better. It's going to be a little bit more expensive, but look at the entire thing with regard to maintenance of tolerances on your shaft for the seal and for this, and then putting them together. So simple things like that. So next is improving the monitoring activities based on risk analysis. This we need to absolutely look at it, because so that things don't come down through the fingers. So we have looked at all the different considerations from a design for assembly point of view. So in general guidelines, lesser parts and complexity in assembly, lesser features in parts, lesser operations per feature production. Every feature you build up like an autometer, Every feature that you are putting in the vehicle, in the part, the product part cost is going up. Can I use a standard part already available and make small modifications and keep the part number same? Lesser effort for every stage of production. Lesser time for inspection, stage-wise and final assembly. lesser carbon footprint, CBAM, lesser cost. All these are the drivers for our checklist for DFM considerations. And greater tolerances so that you maximize your tolerances, greater number of standard parts, greater number of functions per feature. If you put a feature on your 3D model, they have to address multiple functions so that the per feature cost comes down. Then greater material utilization. What do I mean by that? Lesser scrap. I look at how I can use the material effectively. Greater environmental friendliness, greater modularity. Modular designs can be adopted across many assemblies in a completely different fit, form, functional requirements. Greater quality and greater fit and finish. These are the guidelines for DFM. You put this all in an Excel sheet or whatever, or you have a PDM or a PLM, you put them together, put it as a part of your workflow, gets done. Each stakeholder takes a look at every one of them. Not the same design engineer has to look at it. It's the design engineer, cross-functional team, along with your supplier, you need to look at this. We did one design on a pump many years ago, and we called the tooling people for a design review. In one design review in 45 minutes, 21 DFM parameters came out, which I wouldn't have looked at it from a design point of view. This was 15, 20 years ago. So I need to accept the fact that I don't know much. And these kinds of guidelines is what is going to help me to search for the answers, the right answers. So the benefits are lower costs, no brainer, reduced downtime, no brainer, enhanced quality because you're keeping that in focus, improved reliability, improved safety, and extended equipment lifespan, both the equipment that you're using inside to manufacture, as well as the equipment that you are producing, the product that you are producing. How to implement this as a process? Put a checklist together. If you want a checklist, we have developed painstakingly some checklists over a period of many years. We will give you the QR code for registering on our channel. You will be able to write to those channel people and they'll be able to give you the checklist right away. So transform from a manual process into a digital workflow and put this checklist right there. And you keep adding more and more or removing something from the checklist based on the data that you visualize and analyze to find out what is working and what is not working. This is important because in FMEA, now you have what is called as reverse FMEA. You do a DFMEA, there's something called as reverse FMEA. Did it really work? Did the process FMEA, did it really work? People are asking for a reverse FMEA document. So establish the checklist based on things gone right and things gone wrong. Just because something has gone right, it does not mean it should not be checked. Right? Stage-wise, you have to do it and update it periodically and emphasize on the reduction and elimination of waste, material usage, resources over a period of time and time as a part of the continuous improvement process. So design takes the lead role, listening to manufacturing and listening to inspection and coming up with processes so that many of these things can be addressed at design frame before the ugly head of the hydra comes up subsequently down the line in terms of problems. So the summary of this is, if you want first time right or right first time, whichever way you look at it, both are important. Lower costs, checklist for compliance, and knowing pretty well that design accounts for 85% of the product cost, and DFM becomes a lifeline in the organization because profitability improvement and quality and reliability enhancement and solving issues upfront needs to be a priority number one, job one. Thank you.
Thank you, Natarajan sir, for the wonderful session. Along with this, we have our upcoming Innovation Day 2025 and SolidWorks 2026 launch which is going to happen across cities at Coimbatore and Trichy. So at Coimbatore, it is happening on November 13th at Hotel Merlis, and at Trichy, it is going to happen on November 20th at SRM Hotel. So this time, the innovation is based on Tamlar Panbadu, that is Solidworks Tiruvalla. And we are happy to say that we have successfully completed the innovation at Chennai, and I thank the people whoever who has attended the event. And an upcoming event, we have a few technical sessions by Natarajan sir on topic intelligent design and profit maximization by design. So now you have the QR code, so you can scan and register. If not, the registration link will be given in the chat box. You can check the registration link and you can register via it.
Click on the QR code and get onto the WhatsApp channel. We'll disseminate the presentation as well as the Excel-based checklist to you. Thank you very much for taking your time to attend this program in your busy schedule, especially after Diwali week earlier this week. We thank you for your time and patronage for these kinds of programs. It is only your encouragement which takes us to develop these kinds of so that knowledge sharing can happen. Have a wonderful week. Thank you.